Okay, I'm starting the stream. Just give me a second. Just getting things set up here. Okay, it should just be another second, and the stream should be ready to go. Okay, cool. So I'm gonna start the stream now. Today I'm gonna be continuing working on my static bug finding tool. And particularly what I'm going to be doing is I'm just going to be throwing it against a lot of just random projects off of GitHub, and I'll see what it finds. Just responding to someone in the chat. Okay, cool. So I'm going to pull up GitHub and start going through some projects, cloning them, compiling them, and just running Phalanx against them and seeing what it finds. This will be fun. GitHub.com. Okay, cool. Search GitHub. Now, what type of projects do I want to search for? I'm going to be searching for DNS servers. The reason why DNS servers is I know with previous side projects I have experience just exploiting them. I think I have like a DNS fuzzer in one of my repos that I found. And also another thing, I know already I have about, what is it, 9 other GitHub projects that I've already found bugs with. Yeah, these 9 right here. So I want to trying to effectively grow that. Okay. Give me a second. I'm going to pull up the chat on my other monitor. I accidentally closed it. Okay, so Scott's asking us for a quick overview of the bug finder, so I'll give that. Effectively what it is it's a Ghidra JavaScript. It will attempt to find bugs via just it will look for references to certain standard functions such as fgets, read, fread, printf, scanf, sprintf, and effectively analyze them to determine if certain bug types are available. If you want to go into like how exactly I made it, design choices and all of that, made probably like 5 videos so far on that. And okay, cool. So getting back to this, let's try to just find some random DNS servers off of GitHub, throw a Phalanx against them, and see what comes up. So, actually, I want to find projects written in C only because C has memory corruption bugs. So, oh wait. Okay, I'm just gonna go to page 10. Actually, let's try this one right here. DNS echo user. Okay, yeah, I'm just gonna clone this project and let's see what happens. Let's see what we find here. Oh, hey, Squish in the chat. Okay, let's go into actually. Uh, okay, I'm gonna clone the project now. Cool, let's go in there. Can we compile it? Building. Okay, apparently we have to run some commands first. Auto. Let's try this. Okay, apparently it's not just straight running a makefile. There's some configuration that needs to be done before we can actually compile this particular project. While this is running, I'm just going to go ahead and make sure that okay. Wanted to make sure that the search method that this tool had was all references were iterate through all references to all of the defined functions I have checks for. Okay, let's try this. Okay, no, this project is not compiling. I'm just going to move on to the next one. Let's try. Okay, let's try this project, see what happens. Compile it. Okay, it looks like this option has a compiling for Android for some reason. I'm gonna just edit out that option. Nope. Oh yeah, it's compiling for Android. Yeah, this project was written for Android. I don't want to deal with that right now, so let's try another project. Okay, so this compiled, we have the DNS binary. Okay, cool. I'm gonna try and throw a Phalanx against it, which Phalanx is the static finding tool, and let's see what happens. So going to the support directory, this is where the headless analyzer is. I'm gonna just type out the command for it. And we need to import the binary since this is the first time we've dealt with this particular binary. And then specify the script. Oh, yeah, the Ghidra script, which actually finds the bugs for us. And let's give this a second to run. Okay, I found a lot of variable mem copies. Okay, I'm gonna open the binary in Ghidra and take a look at these flagged function calls and see if any of them look interesting. So let's fire up Ghidra, or like the GUI version of Ghidra, I should say. Just gonna throw the DNS binary into here. This VM is kind of lagging a little bit. Okay, let's import it into the GUI project and let's open it up. Yeah, this VM is definitely lagging a little bit. After the stream, I'm gonna up the resources for it. Just want to analyze it. Okay, let's start looking at some of these flagged function calls. So first mem copy is here. Let's jump to it and see what we have. Local 38. What does it say? Oh, okay, so local 38 is a char pointer that is set equal to a malloc or a chunk from malloc. Scanning an n bytes, n is equal to local 4b, which is also passed to malloc. So it's scanning in data into a malloc chunk where the size of the write is also the size passed to malloc. So not particularly interested in that one. Let's take a look at this one. Here, okay, yeah, same scenario. It's writing into data into a malloc chunk where the size of the write is equal to the size of the argument passed to malloc. Let's take a look at this one. Mem copy, okay. Scanning it into local 4a, which is set equal to a malloc chunk. Wait, if no, it's not, because this code will only execute if this code doesn't, because of this if then statement. So where is local 4a established? It's not set equal there. Local 4a, it's initially set to a null pointer here. And oh, okay, so this is a do while loop. Local 4a is initially set to null pointer here. This if then statement will run if this is equal to 0, which it will be the first time since it's written right there, 0 nowhere else I'm seeing. So it'll be set equal to a malloc chunk and then written. Now my question is local 4b, does that local 4b is set equal to the output of this, or rather dereferenced output of that, and it's changed. Could there be a scenario in which I'll probably look at some of the other bugs to see if they'll be a bit easier to quickly verify if they are bugs. One thing I'm kind of curious of is, so can we first get a malloc chunk of local 4b to be like a size, let's say 10, and then increase it? Because if we can do that, then potentially we might be able to get a heap overflow here. Or something like that. Okay, cool. Moving on to the next one. We just did that one. Let's take a look at this call right here. Mem copy. Local 2a. Okay, yeah, same thing. With malloc and the write being the same size. Local 20 equals source equals malloc oxff. Okay, cool. So source is being set equal to a malloc chunk of size oxff, where the size is being ANDed with oxff, so oxff is the max size that can be written. And Yeah, that looks right. Yeah. So this is not an overflow that we have here. I'm pretty sure this is the next one. Elon. Yeah, same thing with the malloc in the right being the same size. So let's go over. That's 1, 2, 3, 4, 5. Let's look at. I believe this is the next mem copy call. That's the one we just looked at. This is the one below it, and let's take a look at this one. Mem copy. Writing an n bytes from local forward to forward equals create name. N equals local. Where's local 52 coming from? Oh, the address is being passed to create name, probably the size. Let's take a look at this create name function. Param1 to dereferenced equals. Okay, yeah. Looks like it's pretty much just actually let me go back here. I'm gonna start looking at some of these fread calls. Maybe they have something interesting. Wait, no, that's... Okay, here's an fread call scanning into local 118, so scanning into a stack buffer, okay. The size is 1 of the integer at local 11D, which this is a while true loop, so this will run repeatedly. Where is local 11D written to? It's written here. Okay, I'm gonna start renaming some of this. So, destination, size array. Okay, so size array gets written to here with fread, and then 5 bytes get written to fread or size array right here. Does a check right here just to verify. I'm just gonna fread returns the amount of bytes written, correct? It's size long. Return value unsuccess as free. Return the number of items read or written. Okay, not the number of bytes, the number of items, since the two size arguments for fread, one is the amount of items, the second is the size per item. So this check is just effectively making sure that it read in at least a single item, and then it will scan in amount of data into a stack buffer that is effectively what it got from the previous fread. So if we get user input data into either of these fread, well, if we control the input to these fread calls, we should have a Stack Overflow bug. So okay, cool. This is a piece of code that I want to look at. Now let's try and start getting this set up so we can actually dynamically look at it. Bind. Let's see. Bind. Run it. It just says bind. What is that about? I wonder. Oh. What does the main function here look like? Main run server. So it runs in a continuous loop What is, it says bind, where can I actually, where does that string actually get outputted? I'm curious. Bind, show references, okay. Okay, so it's referenced here right before it calls die. So I'm assuming, judging by here, it probably can't actually bind to the port that's trying to. So I'm gonna just check this real quick. DNS. We could set a breakpoint for right there, 1896. So Scott, I'm looking at the chat. He's asking, is debug info compiled into the binary? Considering that I have symbols like main, yeah, there is some degree of debugging information. And yeah, we can see here, we're at the if then check right after the bind statement, and looking at the EIX register, it's -1, which the actual representation in this architecture of -1 is just OXFFFFFF. So yeah, it's not able to bind. Could be either, probably one of two issues. Either just doesn't have permission to, which should be solved if I run it like that. Nope. Or something else is trying to get at the port. It is server.c. What is the port? Should be in the source code here. HTOMS 53. I'm gonna change it to it's also setting the server address to 8.8.8.8. Now what that is it's like the common Google DNS server. It might be that this is just forwarding it to that. What I'm gonna do is first just try recompiling it and seeing if I changed the, okay, no, that did not work. I'm gonna try to compile it for 0.0. Nope. It is not able to bind. Okay, so this DNS server is like, I'm not able to easily get it running, so I'm just going to move on to another one since we have literally like hundreds. Let's bring back up GitHub. Okay, let's install to run the program. Okay, let's try running this. So nope, doesn't compile right. I don't want to deal with that, so let's try a different project. A simple DNS server. Not seeing a make file, so gonna move on. Okay, let's try this one. DNS. I just want to make sure that this is one I already found a bug for. Nope. Okay, cool. Dude. Is that Chris in the chat? Nice. Okay, cool. So I'm going to go ahead and compile this project. Let's see if first I can compile it. I'm just going to copy this command. Okay, so I can compile it. Let's see, can I run it? Bind, why? So this is the second project where binding is failing. Starting to think the problem is me. Or something with this VM. So okay. So this is where it's trying to bind it in here. Socket, size of address. I wonder. Where does it have the actual, what do you call it? The actual IP address. It might be something I messed up there. Because when I was compiling it, it had me specify that. Actually, one thing I'm just going to quickly do is I'm going to go over to my test binaries I've already verified that I could find bugs with. I'm just going to run DNS server 0 just to verify that I can indeed run DNS server binaries. It's my port. Let's do 500, and host files. Okay, so that can bind just fine. So the problem isn't with me. At least I don't think it is. Okay, let's move on to a different one. Let's try Pico DNS. We found a bug in Pico HTTP and we got it running, so hopefully this will be easier. Does it have a makefile? Yes, it does have a makefile. So when we initially had it or cloned it, we did have a binary, but when you tried compiling it, it didn't work. Okay, yeah, that's not being able to be ran. Let's try another project. What did it compile it out to? Manager miss. Yeah, it doesn't look like that was able to be compiled. Let's try this. Okay, so this was able to be compiled. Let's try it. Okay, this has some weird stuff going on that I don't want to deal with. Let's try this project here. Let's go into source where the make file is. That's interesting to see. We run it and we get a seg fault. Okay, so that one's just too broken to do anything with. Well, this is a more recent one. Let's try it. Don't know how to compile it. No. Let's try this. Nope. Needs files that do not have. Okay, I'm going to try a few more of these projects. If none of them really are working out too much, what I'll probably do is just switch over to like trying to throw this against large old versions of binaries that already have known bugs in them. So that ran. Permission denied. Address already in use. Grep. I'm just going to change the port that it uses to 53. Let's recompile it. What is the address? Okay, this is not working right. Well, I'm going to try looking at a few HTTP servers instead. Maybe they might be easier to set up. Certainly way more with basic HTTP server. Sure, let's take a look at this one. into Linux. Just in build. Sure, I'll run this. Build Linux GCC server.c build.c. Nope, that is not compiling. Nice. No. Let's go to page like 15. Let's try this HTTP server. Okay, this appears to be working nicely. Let's run it on port 5050. Okay, and let's see, does it actually work? Okay, that does work, so we can actually get it running. Cool. Let's try and throw Phalanx at it now. And Phalanx found actually nothing on this project. That's really weird. What is in here? Set. Okay, I think I'm gonna try just one more project, and if that doesn't pan out, I'm probably gonna need to change my approach here. HTTPC. Okay, let's try this one. Does it? Yep, it has a makefile. Did not compile. Does it have a makefile? No, it does not. Okay, let's try this one. Okay, yeah, this will be my last one that I try. Okay, so this one was able to be compiled. While I try to get it to run, I'll throw Phalanx at it. Okay, it can actually run, so that's good. And you see here, Phalanx is found a few different things, so let's throw it in Ghidra and see what happens, or what those calls actually look like under the hood. Yeah, we'd like to analyze this. Okay, I'm just going to go through these flagged function calls one by one. Okay, first off, okay, it is copying with stir copy and then string cat. What is this? What is dest? Oh, X3F8. Looks like a pointer that is stored on the stack. Destination equals set equal to 0 there. Actually, yeah, no, it's a char buffer on the stack. Address, yeah, that makes sense here. Okay, cool. String length. Root. What is this root? Show reference to address. Main. Oh, so this is in the main function. I wonder. I'm gonna break at that string copy, which it happens at OX169D. Let's take a look there. Probably need to actually submit a request to the server to actually get it. What port is it listening on? Let's see if I can actually type 1,000 or 10,000. Okay, we've managed to break here. Okay, it is writing to a stack buffer the effectively location of the web server. What I'm curious of is I'm just going to try this, just give it a huge directory that it runs in and just sees if that is an overflow. So for this, I'm just going to make a huge file name. Actually, let's see, how much space do we actually need? Where is dest is, where is it on the stack? At OX3F8, which is OX3F8, about 1,000. So I'm just going to make 11 directories that are just 100 bytes. Actually, let's make this 200, make it easy on ourselves. Two, three, 4, 5. Okay, let's see, how big is the directory name here? Okay, that is above the... Yeah, that will definitely be enough for an overflow if this works how I think it works. Let's get this binary here. And let's try this out. So if the overflow happens here, we should be able to do this. And let's submit the GET request here. So it will be scanning or writing the string to here in memory. Let's take a look at this. Okay, so just empty bytes until, where is the return address? Saved RIP DA8 CD CD A8. Okay, that's the return address right there. So let's step through. Okay, right there, pretty convenient. And that's the stack canary. Let's step through this function and see if it actually smashes the stack. It looks like it. Yep, RAP. Okay, cool. So that is a Stack Overflow bug where the input is the name of the directory. However, the reason why it's not crashing is, hang on. So we can clearly see here saved RIP is 0000. So we have smashed the stack. However, the reason why it's not crashing, this isn't a while true loop. So this will run infinitely unless if an exit condition is met, which looking through here, the only exit condition realistically is it calls exit, which exit will not execute our return address. So we were able to smash the stack, but not get either the stack canary check failed or the return address that we overwritten to be executed. And also, one thing I'm just going to quickly check for test. Okay, cool. So we were able to, yeah, we were able to find a bug in one of these projects. Now, what I'm going to do is going to just add this to the list and of the 10 or so GitHub projects I was able to effectively find bugs with Phalanx in. And what I'm going to do is I'm just going to implement those 10 projects into like the automated testing for it to help verify that it is A, reliable and does what I want it to do, and B, that what I want it to do can like find bugs and like easier, softer targets. So cool. This has been going on for I think 40 some minutes. Yeah, 40 minutes. I'm gonna end the stream now, but I'm gonna also like right after the stream submit like an issue to this project, just being like, hey, this is a bug. Any questions? Okay, I'm just gonna end the stream here. Thank you for watching.